Okay guys, so today we are solving the question maximum points you can obtain from the cards. So let's take an example. ARR is equal to 623,472,171 and our K is 4. So the question says that there are several cards arranged in a row. These are the cards arranged in a row in a array, and each card has an associated number of points. So at ith 0th location the card has 6 points. At the first location this card has 2 points. So at this location at this card has 2 points. The maximum point which card has 7. The maximum point the card has 7. So these are the points. In one step you can take one card from the beginning or from the end of the row. You have to take exactly k cards. We have to take exactly k cards. So your score is the sum of the points. So how the score will be calculated by the sum of these points of the given cards. Given the integer array card points and the integer k, return the maximum score. We need to return the maximum score we can obtain by taking the by taking the 4 cards only, but either from the left side or from the right side. We can't take these cards or from the middle. We cannot take from the middle. We can only take the cards either from the left or either from the right side, left side or right side. So if k is equal to 4, what are the possible sums we can take from these cards? So we will start from uh, as we know that k is equal to 4, so we will start from the left side by taking the 4 elements. So sum of these 4, 6, 4, 10, 15. And after that we will remove one element from the left side and add one element from the right side. So in this 6 plus 2 plus 3, now we will accept this element and add this element. So this is 1, 6, 7, 8, 9, 10, 11, 12. Again we will take two elements from here, two elements from here by removing these two elements, 6 plus 2 plus 7 plus 1. So like this we will removing first of all we have taken 7. First of all we will take the entire window of length k is equal to 4. After that we will removing one element by element, and at the same time when we are removing one element we have to add another element from the right side. Then we are again removing the second element, then we have to add this element, then we are again removing this element, then we have to remove add this element. And if we will remove this first element from the left side, then we have to take the entire window of length 4 from the right hand side. So I think you got the point how we will solve this question. So suppose this is the array. First of all we will take all 4 elements from here left side, then we will take these elements. After that we will take two elements from the left and two elements from the right, then we will take one element from the left and three elements from the right, then we will take nothing from the left, we will take all the four elements from the right. So by taking this we will do sum of this, sum of this, sum of this, like this, and we will calculate the max sum. Suppose this is s1, this is s2, this is s3, this is s4, s5, s6, s7, s8. So we have to find the max of s1 to s8. Whichever is the maximum we will return that to the question, because in question we need to return the maximum score we can obtain by taking the elements from the either from the left or from the right. So I think you got the idea how to solve this question. Now we will move on to the pseudocode part. So first of all, we have we want a maximum sum. So we are declaring an element variable max sum is equal to 0. L sum for left sum. L sum represents the left sum. R sum represents the right sum. Means this is the array, this is the L sum, and this is the R sum. Initially both are 0. So first of all we will calculate the sum of this entire window from the left side. We will calculate the sum of entire window of length k from the left hand side, and then by removing one element from here, adding this one element from left side window and adding one element from the right side window. So for this we have to calculate for I is equal to 0 to k minus 1, k minus 1, because we have we have to take k elements from the left hand side. So I is equal to 0 to k. We will calculate L sum is equal to L sum plus ARR I. It will calculate in the L sum all the four elements, all the kth elements. Sum of all the kth element is stored in this. And let me write it clearly. So this is the array A, B, C, D, E, F, G, H. So in right now L sum, suppose we have k is equal to 3. So currently L sum contains the sum of these three elements. Then we will remove the element, one element from the left window and add one element from the right side in the window. So this L sum means initially it is initialized with the sum of kth element from left window. Then for I is equal to k minus 1. Now we are starting from here and removing one element of one by one. We will removing all the elements from the left window, and at the same time we are adding one elements from the right side. We will be adding one element. So whenever we are removing one element from the left window, we are adding one element from the right side. So we are iterating from k minus 1 and moving to the left side. K minus 1 is less, sorry, I is greater or equal to 0 plus I. Now whenever we are iterating from the kth minus 1 location, we are removing this element. So we need to remove this, subtract this element from the left sum ARR I, and adding R sum. Now we are adding the element from the right window in the right sum. So R sum becomes R sum plus ARR. We have to take this element. So for this, here we can take one more variable, right index n minus 1. It is representing, it is pointing to the last element of the array. So else R sum is equal to R sum plus ARR, right index. So this line will subtract this from the window of size 3, and at the same time rsum will add this element or the last element of the array into the rsum. Now after this we have to decrease this right index. After this, when we have processed this, we have to decrease the right index for the next element of the right hand side window. So right index minus minus. Now we will calculate our maximum sum. Maximum sum, we will calculate max sum is equal to max of max sum plus comma. We have removed this element from the left hand side and added one element from this, but we have calculated these things separately. These this thing has been stored in LSUM, and this thing, sum of this, has been calculated and stored in RSUM. So we need to add them up. So LSUM plus RSUM, because we have calculated the left sum in the LSUM variable and right sum in the RSUM variable. So we need to combine them to make the window size of k. So this will calculate the maximum sum. Now our for loop ends. So guys, this is the code for the question. Let me explain again. We have taken maxsum, lsum and rsum is equal to 0. These are the variable and initialized with 0. Then I have iterated a loop from 0 to k for calculating the for calcul for calculating the sum of starting kth element from the left hand side. Starting kth element, sum of starting sum of kth element, and stored in lsum. Stored in lsum. So in this lsum we have stored, initially we have stored the sum of these kth element in lsum. Now I have taken one more index, right index, that will that is pointing to the last index of the array. So here lsum as we start from the k minus 1, and by removing element one by one, at the same time we are adding the element from the right hand side one by one. So lsum, we need to decrease this element because we are excluding this element. So we need to decrease. Here we are subtracting, we need to decrease this element from the lsum. So now rsum, we are calculating the rsum, means right hand side window sum. Currently we have k is equal to 3. Currently we have two elements in this window, so we have to include this last element for k is equal to 3, because in this window only two elements are there, we need three elements. So we are calculating the right sum by adding the last index value. So here we have calculated rsum is equal to rsum plus arr, array of right index. Here this is the right index. We are given we are initializing the right index by the with the last value, last index of the array. Now after that we are decreasing the right index, and now we are calculating the max sum by summing up these two variables value and calculating the maximum between the maximum and sum of these two. These are sum because lsum calculates the left side but less than k value, and rsum is also calculating the sum of right value. And for the window size k is equal to 3, we need to sum these two variables, because these are calculating the sum from the left and right side, but combining them we will get k is equal to 3. So we are calculating lsum plus rsum, and in this maximum sum will be stored. After that we will return the maximum sum. Oh, maximum sum. Now let's discuss about the time complexity. Here we can see that let me erase this. So for time complexity, first of all we will see here the time complexity for this is k. It is running for big of k times. This loop is running for k times. and this loop is also running for k times. As you can see that from 0 to k and k to 0. That's why these both are running for the k time. So our time complexity will become big of 2k, that is k plus k. K time for the calculating LSUM and k time for calculating the right side sum. So time complexity is big of 2k and space complexity is big of 1, as we are not using any extra space here. That's why space complexity is big of 1. So these are the complexity part. Okay guys, thank you.